Okay, so what we're going to do is we're going to discuss heating and cooling curves. This is a heating curve, and on a heating curve, you have the temperature increasing on this axis, and you have time increasing on this axis. Now, as time increases, temperature increases. We know by our definition of temperature that temperature is just a measure of energy. So on a heating curve, energy is always increasing. And because energy is always increasing, we know that the substance is absorbing that energy, and that makes it an endothermic process. Now, there are two types of energy when we're talking about increasing energy and absorbing energy, where there's two types. One is kinetic energy, and kinetic energy is an energy of motion, meaning that the actual molecules are moving around more, and that increases the temperature. We also have potential energy, which is the energy that comes from a change in phase. So it's not necessarily that the molecules are moving any faster, it's that they are spreading apart so that they have room to move faster. So potential energy comes from phase changes. So either solid to liquid, liquid to gas, or the reverse. Potential energy comes from phase changes, and it is the ability of a molecule to move around more. Now, on the chart, on this curve, you have two areas of energy increasing. You have kinetic energy increasing, you have potential energy increasing. Kinetic energy is where the line is increasing so that the temperature is actually increasing. Whenever the line is going up, the temperature is increasing. But there are two segments where the line is staying still. This is the phase changes. So this would not be a kinetic energy increase, this would be a potential energy increase. When the temperature increases, the kinetic energy increases. But the potential energy has no change on these portions because it's not changing phase. When you have the blue areas, or where it's changing phase, that is where the temperature is not increasing, the kinetic energy isn't increasing either, but the potential energy is increasing because it's a phase change. So all of the blue areas, or all of the phase changes, you're seeing an increase in potential energy, and every slanted line is going to be an increase in temperature, therefore an increase in kinetic energy. But the potential energy isn't going to change. So the entire curve, energy is always increasing. It just depends on whether or not it's the kinetic energy or the potential energy.
Thank you.
Now in the cooling curve, it's the exact opposite. Energy is decreasing. That makes this an exothermic process. On the slanted lines, the kinetic energy is decreasing because the temperature is decreasing. We have the gas phase, the liquid phase, and the solid phase. The temperature is decreasing in all of those phases. On the flat lines, or the purple areas, you have a phase change going on. So the molecules are actually becoming closer together, losing that ability to move more, and therefore they are losing potential energy. Cooling curve, energy is decreasing. Exothermic process, again, the energy is being lost throughout the curve. It's just depending on whether or not it's kinetic energy that you're losing or potential energy that you're losing.